Hello. Today we are doing lesson 925. This lesson is really nothing new. It's applications of the Pythagorean theorem. Just as a reminder, the Pythagorean theorem from a few lessons ago is a squared plus b squared equals c squared, and we use that in right triangles when we need to find one of the side lengths. So for today's lesson, I'm just going to pick a few of the core problems right out of the book and work those out here with you in the video. So I'm going to put the book right underneath here, and we'll start with just 9.122. It says Anne is measuring some fabric pieces for a quilt. Use the Pythagorean theorem and your calculator to help her find each of the missing lengths below. Decide whether each answer is rational or irrational. If it is rational, explain whether the decimal repeats or terminates. So we have a few different things that we need to do. Let's start with the first one, which is part A. We have a right triangle. I always think it's a good idea to sketch and label what you know about the triangle. We know it's a right triangle. We know that its height is 32 inches and its base is 24 inches. What we don't know is this diagonal side, which in a right triangle we call the hypotenuse or side C. So we are going to use the Pythagorean theorem to figure this out. I'm also going to grab my calculator here and have it handy. All right, let's plug our numbers in to the Pythagorean theorem. The legs, which are the two shorter sides, are sides A and B, and remember it does not matter which one's A and which one's B. I just happened to pick these ones. So I'm going to plug 32 in for A. 32 squared plus 24 squared equals c squared. Definitely need to use my calculator to help me here. So 32 squared is 1024, and 24 squared is 576, and I'll find that sum in just a minute. So that's what we have so far. Now I just need to add 1024 to 576, and I get 1600 for my sum. So what number times itself equals 1600? I would take the square root and find that the side that we labeled C is equal to 40 inches. Now we know our first answer, it's 40 inches long, but they asked us to do a few other things also. First, find the missing length, then tell if the answer is rational or irrational. We have here a counting number, which is rational, so I'm going to label that. If it is rational, explain whether the decimal repeats or terminates. Well, the way I have it written right now, it's not a decimal number, but I could certainly write it as one. That is a terminating decimal because it has an end to it. It doesn't repeat, so it terminates. Okay, now we've answered everything that they've asked us to do, and really if we were to circle our answer, we have to circle all of this. They asked us several different questions. Okay, let's move on and do part B also. Same directions. I'm going to sketch the triangle that I had showed you earlier. Looked something like this. It is a right triangle, and this time they told us that the height is 10 meters. Wow, that's a big quilt if this piece is 10 meters long, and the hypotenuse is 20 meters long. So we need to find that missing leg down at the bottom or the base of the triangle. Let's call this A this time, this B, and this C, and that will help us with plugging it into the formula. A squared plus B squared equals C squared. Okay, A is our unknown, so A squared will stay a variable. I'm going to substitute 10 in for B, 10 squared, and substitute 20 in for C. Okay, so now we just need to square, well, we can't square the first one because it's a variable, it just stays A squared. 10 times 10 is 100, and 20 times 20 is 400. To solve this equation, I need to get A squared isolated or by itself, so I'm going to subtract 100 from each side. A squared equals 300. What number times itself equals 300? Oh, I'm not real sure on that one, so I'm going to use my calculator for help. 300 square root, oh, look at that. A is equal to 17.3205080808. That gives me a little dilemma here. I am going to round to the nearest tenth, which was our standard rule when we have long decimal numbers. So side length of A is approximately equal to 17.3 meters. This is a rational number because it terminates. Back on my calculator though, it did not terminate. It continued on and on. So it didn't terminate. And didn't repeat that I recall. May have to go back and double check that part, but I don't believe it repeated, which means it would be irrational. So I am going to check that really quick to make sure that that was correct. Okay, so our original answer only ended because our calculator made it end. We ran out of room, so it didn't terminate, it didn't repeat, and the original answer before we rounded it was irrational. But when we say the length of that missing side, we do give the rounded answer 17.3 meters. Okay, we are going to move on to our next core problem, which is 9-123. I'm going to put the book under here again for our reference. Here's our problem. Coach Kelly's third period PE class is playing baseball. The distance between each base on the baseball diamond is 90 feet. Lisa, at third base, right here, here's Lisa, throws the ball to Dano at first base, right here. How far did she throw the ball? State whether your answer is rational or irrational. Okay, so I'm going to give us a little visual here. That's where the path of the ball traveled, and the question is, what's that distance? So visualize this baseball field. Let's just say we start at home plate. We could go directly out to third base, and we can go directly out to first, and the baseball diamond has right angle corners between the bases. So let's translate that into a diagram here. We have third base, we have home plate, and we have first base. So here's the paths that the runners take, or the baselines. The distance that the ball was thrown went right across here. Hopefully the pitcher got out of the way when that ball was thrown. The information in the problem told us that these are 90, I believe it was feet, right? Yes, 90 feet between all of the bases. But that is not the distance here. So we know we've got a right triangle which means we can use Pythagorean theorem. These are our two shorter sides. The hypotenuse is always across from the right angle, so this would be side C. So let's plug those numbers in the Pythagorean theorem and see what that distance is. C squared equals A squared plus B squared. Okay, this is our unknown distance. We have 90 squared plus 90 squared, right? C squared is equal to 8100 plus 8100. Add those together. Okay. What number times itself is equal to 16,200? I'm going to use my calculator to help me with that because I need to take the square root of each side. 16,200 square root. Okay, let's see. We have a decimal number that does not appear to terminate, and it definitely does not repeat. So that tells me it's going to be irrational. But in order to write our answer, let's get that written down here first. It's 127.2, but the next number is 5 or greater, so it's going to round up to 0.3 feet. Is the distance between third base and first base. Now to answer the next part of the question, it says, is our answer rational or irrational? Our original answer, which is on the calculator, is irrational. It was a decimal that did not end and did not repeat. Okay, the next core problem, and also the last core problem that I'm going to go over with you, is problem 9-126. It says, Scott and Mark are rock climbing. Scott is at the top of a 75-foot cliff when he throws a 96-foot rope down to Mark, who is on the ground below. If the rope is stretched tightly from Mark's feet to Scott's feet, how far from the base of the cliff directly below Scott is Mark standing? Draw a diagram and label it. Then find the missing length. Is the length irrational? All right. Yay, drawing. My best subject. Not really, but I will give it my best effort. So, we have a guy who is standing on the edge of a cliff. Okay? And this is Scott. And they tell us that Scott is at the top of a 75-foot cliff. Okay? Then we've got his buddy standing on the ground down below. Okay? His buddy, Mark, is down here. And Scott throws a rope to Mark and then secures it with his foot, and Mark secures it with his foot. And that rope that he threw was 96 feet long. Okay? And the question is, how far is Mark standing from the base of the cliff? Or what is this distance right here? You can see that we ended up with a triangle. The ground and the cliff form a right angle where they meet. If we're going to use the Pythagorean theorem, which we are, we know that this is the hypotenuse, side C, the longest side, and then the two shorter sides, the legs, are A and B. So now we know what numbers to plug into which part of our formula. A squared plus B squared equals C squared. So 75 feet squared plus B squared equals 96 feet squared. Okay, let's figure out what is 75 squared. 5,625 feet. And 96 squared is equal to 9,216 feet. Now we need to isolate b, our variable, so we are going to subtract 5,625 from each side. And we get b squared equals 3,591. Our last step is to take the square root of each side to find that distance. So square root. It definitely looks like another irrational number because it does not end and it does not repeat, but we are going to round to the nearest tenth for our answer. So the length is 59.9 feet along the edge of that cliff. I just got a notification that I have a meeting starting, so good thing we're almost done. And lastly, our original answer on the calculator here was irrational. It was a decimal number that did not end and did not repeat. All right, the rest of your assignment, which you are supposed to do today, is to complete review preview problem 9-129 and 9-130. If you are following along with our April calendar, today is, where did it go? Today is, May 1st actually. You just did the video lesson. You're going to complete these review preview problems, and you're going to submit your work for this whole week to me, please, by email. Thanks, guys. Have a great weekend.